Yeah, we're live. It is 1:07 in the PM, I guess, in the afternoon. Today, I want to talk about. Oh, did I put my? I need to. Let's see here. Yeah, I did. I have it up. Okay, we're good. Okay, I just want to make sure I had the thumbnail up, and that is a small block Ford stroker. We're going to talk about two of them. One of them is a 331, so it's the 325 stroke. Small block Ford 302 base motor, and then also a 408 stroker because I ran tests on both of those. In fact, I might revisit the video on this. This is lots of good information because not only do we test different intake manifolds, but we also tested different throttle body sizes. So it gives you a pretty good idea on what's going on with the different power changes from these combinations. So we've got, let's take a look here, 39. 54, 15. There we go. That's good. Plus 15 horsepower. So what we want to talk about is the comparison test is, we'll start off with the 331. So we had a 331 stroker. It was a forged rod, forged piston deal. The crank actually was a cast crank. It was a scat crank. And we had CNC ported trick flow 185 heads on it back in the day. We had the 274 extreme energy camshaft in it, like we run on lots of stuff. It had roller rockers on it. They were standard ratio. They were 1/6s. I think that they were the heavier stainless steel ones, which is kind of part of why we ran into an issue, that and the available spring rate on the cylinder heads. We ran into a spring rate or a valve control problem at the top of the RPM range. We still saw some pretty big gains here. So what we did first was run it with a trick flow. We ran basically three different trick flow. We actually ran four trick flow configurations. So we started with the trick flow R lower intake manifold, and then we ran the trick flow R upper intake manifold, which is the longish runner, at least compared to the box R. Not as long as the other ones, as the Street Max and the Track Max thing. Street heats. So we ran that combination, and it made 416 horsepower and 396 foot-pounds of torque. So it did okay. I've never really been a big fan of that particular intake manifold. It just never has performed as well as I thought it should have. And this is a perfect example. So what we did then, and we ran that with a 75 millimeter throttle body on it, because that's what the opening was designed to accept. We then replaced that with a box R upper intake manifold, just the upper portion. So then put the box R in there, and then we had this thing dialed in with this was a fast XFI setup, I think, way back then. So we put the box R on there, and what we did was put the box R, even though the opening was designed to accept up to a 90 millimeter throttle body, we started off with a 75 millimeter throttle body. So we put a 75 millimeter throttle body on there, and then put the box R intake manifold on there, and the power jumped up to 439 horsepower from 416. So 23 horsepower and 410 foot-pounds of torque. So the combination not only made more power, and I can look at the curve here, but basically the box R was better from 4,000 all the way up. It dipped down just a little bit below the longer runner TFS R intake manifold. From a short range from 3,400 to 3,900, but down below that, they were actually pretty equivalent. So we saw good gains from 4,000 on up on the box R manifold. Like I said, we went from 416 to 439, and peak torque was up a good bit. And peak torque happened quite a bit later in the RPM range with the box R intake manifold. So then what I did was we tried running the AccuFab. It probably still does, but back then they made two 75 millimeter throttle bodies. They made a 75 millimeter throttle body where the blade is 75 millimeter and the opening is basically that. It's got a slight radius entry on the edge of it, on the very entry portion of it. But they also made one that was a tapered 75. So it tapered out basically to, this one went out to, I think, about a 90 in the opening. So the opening of the throttle body was bigger, but it necked down to the blade. I think that they did that for Renegade or one of the classes back then, where they mandated that size throttle body, so that they were trying to improve the flow rate of the throttle body by tapering this entry. We tried that on there, and that didn't really seem to show hardly any of a change in power. So what we did then was go to the 90 millimeter throttle body, because the opening in the box R upper was designed to accept the 90 millimeter throttle body. So we put the 90 millimeter throttle body on the box R intake manifold, and the power went up again from 439 to 454 horsepower. So we picked up about another 15 horsepower going from the 75 millimeter throttle body to the 90 millimeter throttle body. And again, remember, this is only at, like, now we're making 450 horsepower. So it goes to show you that throttle bodies don't always do what you think that they will do based on what the airflow of the throttle body is and how much power it will support. If you think about what we're doing on LS stuff, the factory throttle body is bigger than a 75 just to start out with. So back in the 5-liter days, a 75 millimeter throttle body would have been the big one. The 90 you wouldn't even use. I wouldn't even use that on a street car because it's just way too big. And now 90 millimeter throttle bodies come factory on lots of motors. And as long as you can get the opening rate right and make them not be touchy, and on a motor like this, that's not really a problem. This thing would certainly be drivable even with a 90 millimeter throttle body. And it goes to show you, if you compare it from our beginning with the TFSR upper intake manifold, putting the box R and the 90 millimeter throttle body on there, we went from 416 to 454, so almost 40 horsepower just from that upper manifold and throttle body change. And the 90 really won't go on the R intake manifold because the opening isn't set up to accept that. So you'd have to, you have to go in there and machine it out if you wanted to do that. And honestly, I don't think that we saw what the 90 did compared to the 75 on the box R intake manifold, but the box R, even with the 75 millimeter throttle body, picked up a lot of power that had nothing to do with, because they ran the same throttle body, that had nothing to do with the ultimate flow rate of the throttle body. If they were being restricted, they were being restricted by the same amount. Actually, in our case, the box R was probably being restricted more by the 75 millimeter throttle body than the TFSR upper was, because it just didn't make as much power to begin with. So we saw a gain in power going to the box R, saw another gain in power going to the 90 millimeter throttle body. So all of that worked out really well. And we ran another test with this box R intake manifold on a larger 408. So this 408 was a 408 stroker. Again, it had I think this had a scat rotating assembly in it. It had a set of Airflow Research 205 heads. It had a bigger camshaft than the 331 did. It had that Extreme Energy 236 cam. So it was 579 lift and a 236, 248 and a 114, I think. So I want to verify that, but I think it is I think that XFI camshaft is a fairly wide LSA. Yeah, it says 114 on it. That's what I thought. And then I'm going to bring up this thing so I can reference this for myself. So what we see on this 408 is, because we compared it to a Super Victor intake manifold, so that we ran this thing first with a Super Victor intake manifold. And with the Super Victor intake manifold, and I want to make sure that I know I think that this is probably a 950. It was an 850 carburetor, an 850 Demon. And with the 850 Demon, this combination produced 544 horsepower and 510 foot-pounds of torque. Then we put the box R intake manifold on there and ran it fuel injected, obviously, instead of carbureted. And then we saw a pretty dramatic change in the power curve, kind of like we see when we compare a single plane intake manifold to a dual plane intake manifold. What happened with the box R is it obviously has longer runner length and probably smaller cross section than a Super Victor does. And the box R might have more even runner length than the Super Victor does. Super Victor, typically on a Ford, the 4 inner runners are shorter than the 4 outer runners, which are longer. And so they have kind of a staggered runner length for the 2 sets of 4 on the Super Victor. But with the box R, the peak power was 525 horsepower and 530 foot-pounds. So it was down by about 20 horsepower, 19 horsepower, and then up by about 20 foot-pounds of torque. So basically, it kind of traded. They rocked the curve right at about 52 or 5,300. The single plane made more power after that, and the box R made more power below that. All the way down, we loaded this thing at like 2,900 or 3,000. And the biggest difference in torque was 474. This was at 3,700. 474 versus 509. So 25 and 10, like 34, 35 foot-pounds. So pretty good amount down there. And you definitely feel that. Let me know what you guys think in the comments. What do you think about the 850 versus the 90 millimeter throttle body in terms of flow? Are we limiting flow on this thing at this higher power level on this combination because of that 90 millimeter throttle body? I mean, if you had a 550 horsepower LS motor, would you think about changing the 90 millimeter to a 102 like on a fast? The other thing to think about is obviously on the carbureted combination, we have a charge cooling effect offered by carburation itself. Just the introduction of fuel at the top of the, what is the carburetor flange, but basically the top of the intake manifold. So there's a cooling effect, which we know adds power to that the EFI setup doesn't have, because the EFI is injected basically down at the joining section, or where the intake manifold meets the cylinder head. So the fuel is basically being sprayed into the head port, kind of at the back of the valve, depending on the angle of the injector, but it's being sprayed right there. And so it has much less time for charge cooling. So some charge cooling may be happening at the lower engine speeds, where there's more time for that to happen. But all the charge cooling would have to happen in the combustion chamber. And again, as we go up in engine speed, there's less time for the heat transfer to take place. So we do have more charge cooling with the carbureted combination than the EFI combination. So it has a benefit there. But it's interesting that on this combination, what we see with the change, like on the 331, what we saw with the different intake manifolds and then the different throttle bodies, and then also on the 408, the reason that we ended up running the 408 with this box R intake manifold is because we would later put a single turbo on it. And then, then if you're starting out with something that makes more than 500 horsepower, pretty easy to get to big power outputs. And this was done with a standard late model 351 hydraulic roller block is what we built this 408 out of. But it worked good. We used it for a lot of testing. We had the airflow research heads on it, so we had more than enough head flow, obviously, to support this power level. In fact, we could, I think easily go up probably another 50 in NA power, and still have the airflow research 205 heads, good heads. Same thing with those on the 331, the 185 CNC heads from Throttle. Those are also really good heads on that sort of displacement, and that combination worked out well. We were just kind of scratching the surface of what those heads were capable of at our 454 horsepower power output when we ran the bigger throttle body and the upper intake manifold, the box R intake manifold. But cool stuff, and that was fun testing on both of those. And I think that the reason that Trickflow came out with that box R intake manifold is because especially back in the day, those were so common. These boxes from Downs and Hartman and Cartech, and just replacing the upper intake manifold, whether on various different kinds of lower manifolds. So whether it was a stock HO or the GT40 style or the truck or the Celine or the Holly version. So different kinds of boxes available for those. And basically those are all the same thing, just shortening the runner dramatically, getting rid of almost all the runner length in the upper manifold to change where the thing makes power. And at least initially early on, the selling point was, yeah, you don't need runner length for boost. We know that you do, because it does the same thing. And so if it's beneficial one way, it's beneficial the other. And if you want to shift power higher in the RPM range, shorter runners definitely do that. And as we saw with you take a look at the top secret AccuFab dual oval blade video that I have up, you'll see that did exactly the same thing. It just got rid of all the runner length. And in this case, we just had two big open blades there. But getting rid of the runner length was really the dramatic change. And we saw a similar thing where we picked up power up top and lost power down low. And that's normally what we see. And if we would have added boost to that, it still would have done that same thing. So let's see what you guys got going on this fine afternoon. Let's see. Okay, would you run a 90 millimeter throttle body on your stroker forward for the street? Or is it too big? Yeah, I can't add that because then you're going to have to answer two different questions. For the street. But basically, do you think the 90 millimeter throttle body is too big? Would you run a 90 millimeter throttle body on your stroker forward for the street? Love the live feeds. Craig, what's going on? Winston, Dylan. Good morning. Queensland, Australia is in the house. We like that. LT1 Camaro. I still need to redo the LT1 test. I'm certain that there's something going on with the EFI combination that's not correct. Melbourne, is it cold there, Jimmy? What's the temperature there? And please don't give it to me in Celsius because I can't calculate that in my head. Eric, what's going on? Thanks for the small block Ford tech. Yep, we've got some small block Ford stuff going on. Throttle body has gotten ridiculous, but you just got to get with the times and go big. That's right. And the LT1 stuff is a good example. Those are pretty small throttle bodies. I mean, dual 48s is pretty small from the factory. 9 thumbs up. Scott, I like that. Is a Ford Explorer 8.8 a reasonable budget option for rear ends, or do you just stick with a 9-inch for the endless aftermarket support? The 8.8 stuff, there's lots of guys going fast with 8.8 stuff, and there's an endless amount of 8.8 aftermarket support. Hope everyone's staying cool. 97 degrees and 92% humidity in New Hampshire. that is really hot. Richard, I've seen an issue before with a thermal switch not grounding, I'm thinking is what you're talking about, in an inlet manifold because of thread tape. Seems like you have to have a lot of thread tape for it not to ground, but if you had enough on there, the ground may not be good. I mean, it's really easy to check. Just, take the thread tape off and see what happens. I mean, I don't think it's a pipe plug anyway, so it really shouldn't leak. Or just put some thread sealant, the liquid stuff. That's normally what we use. We normally don't use thread tape, but just put it at the very top of it. So it's still getting metal to metal ground, and you're only sealing at the very top of it. Richard, I might have missed it yesterday, but do you have dyno results on a 550 horsepower engine comparing a 90 and a 102? I don't think that I do. I'd have to go back and look and see when I did that test. I have to go back and look and see what the power output was. Finally got all the stuff ordered to seal up a 5.7 Hemi. Finally get to start saving for the chassis components for the Speedway T-bucket. And you have a T-bucket and you're putting a 5.7 Hemi in it. That'll be pretty sporty. You're selling a bunch of your Hot Wheels, Eric? Winter has just kicked in. It's 39 degrees Fahrenheit, but it's still early in the morning. Okay. I keep forgetting it's different seasons in different places. It's been warm here for the last few days. As a side note, I went yesterday and was looking for snakes. Well, my son was playing soccer and I didn't find any, but I found a bunch of sheddings, and I found something interesting that I had not seen before. There's an area that I was looking at, and I came across a shedding that was fairly new. In fact, it was new enough that I started looking around for the snake that I think had just come out of there in the direction of the shed that was pointed. And I was looking around for him, and it was a good time because it was like 8 o'clock or so. So sort of, the sun was kind of starting to set and stuff. And so that's a pretty good time. It'd been better if it was, because it was warm that day. So it'd been better if it was later on, but I was hoping he was around, but he was not. But I kept looking, and right in that area, about 2 feet away or 3 feet away, I found a hole going underneath a big cement slab. And the interesting thing about the hole is that that's not unusual for those and to find snakes there, especially under a big cement slab. That's very common. But there were two different sheds coming out of the exiting that hole. So 2 other snakes had come out of that same hole at some time, and both of those had shed in exactly the same spot. So they had peeled all of their skin off their shed, hooked in the same area. So maybe one of them went in and told the other, hey, dude, you're shedding, man. You need to go take care of this right over here. Here's like the beauty shop for snakes. You just go over right there. And I'd never seen that before. I'd never come across an area where there were multiple snake sheds in the same spot. And so it's obviously tells us a couple things, that at least 2 snakes have come out of there. And the fact that there was another one a couple of feet away tells me that there's probably quite a few snakes under there. So I'm gonna be checking back at that spot from time to time and kind of see what's going on. I might go there like at night and see when they're coming out. It would be really cool if I could install like a trail cam or something to like keep an eye on that remotely, but it's just not in a good spot. The trail cam, I'm sure, would disappear if I put it there. So I bought a running 6.0 that the guy said overheated. Still runs, but backfires out of the exhaust once in a while. If you're a betting man, do you think it burned an exhaust seat? You could look at that. The nice thing about that is if you bought the 6-liter and got it cheap enough, I'd take it apart and see. If you just have to go get another wrecking yard head or 2 wrecking yard heads, that's a cheap deal. Did it maybe just blow a head gasket or something? What did it do? You need to take a look at it and see, and maybe take it apart and see if the thermostat is stuck on it, if it overheated. Sometimes that's a culprit. Sometimes if the fan clutch is bad, if it's got an electric fan on it, if it was electric fan application, electric fan's not turning on. 95 degrees here in New Brunswick, Canada. Humidity down at 41%. That makes it a little bit more tolerable. The LT1 setup was extremely mild. The cam was spec for a TPI, and the heads are probably just cleaned up stock castings. I don't know which one you're talking about, Camaro. Throttle bodies have gotten ridiculous. Yeah, I don't know what LT1 setup you're talking about. Eric, wow, you made that much off of your Hot Wheels? That's cool. Do you have a TFS 51403-003? I don't know what that is. I don't know part numbers. Richard, I just put a Gen 3 Hemi short motor. I changed the rod bolt, but reused the main bolts. Are these torque to yield? Should I replace them? I would look online. When I take apart an LS or a Hemi for the Big Bang motors, I don't replace any of that. We just reuse them. And I just redo the factory torque specs on both of them. Found a crazy long lizard under my tool shed this morning. Didn't know they got that big. What, Roger, what area are you in? My guess, the big lizards that we see, at least in our area, are called alligator lizards, and they can get more than a foot. There are bigger lizards in other parts of the United States. But we don't see them here in California. Skinks don't usually get that big. Single pattern camshaft was big enough for more than 390 horsepower. A Vortec with a spring swap and an LT4 hot cam. Single pattern made 430 to 450. Should be comparable in power. The ZZ409 cam is basically a TPI cam. Well, yeah, I mean, we can argue about all of that, or discuss all of that, but Jim has dyno data on that camshaft on LT1s, and so we know what they do. And this one didn't do that. This one didn't make the power that it should have. I have a 427 with it, but it did seem to make the power with a carbureted combination, and so it just makes me think that there's a I don't know, a fueling issue or a timing issue or something. I have a 427 with good valve train, pro top line. Okay, Matt is. I'm scrolling back, Matt, because you had asked me a question. I thought you did. I could be wrong. 427 Windsor, pro top lines, Super Victor, it's done by 6500. Do you think the cam is holding it back? 259, 268, 108. 259 should be enough. I don't know how much those heads flow. I don't if the heads are not ported and they're an as cast head. I'm sure you're limited by head flow on those. The 108 is hurting you for peak power also, but that should be enough lift to do that. Alligator lizards are in the air. That's right, Dean. Chuck Wallows are the ones that I was thinking of that are in like they would be by the we might have some of those in the southern part of California. Definitely out by the Amboy Crater and stuff. Arizona area, they have those, and those get pretty good size. Should have been 450. Yeah, that would have been nice. All the ones that I've seen that would be in that range, though, because I talked to Jim about a few that he's tested, those all had a few other things done to them. They had at least port match intake manifolds. They had bigger throttle bodies. They usually had non-stock rockers on them. Not that those things are going to combine. I mean, except for the throttle body, which might help at that power level. I don't know how much all of that is going to team up to be, but LT4 hot cam is a 218, 228, made 334 wheel horsepower through an automatic with a hot cam. Yeah, that's good. We'll figure it out. It's got to be something. I mean, it can only be, it can be airflow or timing or fuel. And we know the injectors work because we've used those a lot on other combinations. So it's not those. The ZZ409 cam is a single pattern cam, right? Yeah, 226 single pattern. Single pattern will help it make more torque down low, but 226 is still big enough to make power, though. Scott, TFS 51403003 is a trick flow cam, 236, 248, 110. So I have run that cam a lot. I don't think I have any of those. That's like this cam that we ran on the 408. It just has a tighter LSA than this one's on a 114. That one's on a 110. And that's a split 574, 595. I think this was 579. Comparable. 165 heads. What? 347 with 165 heads. Ported air gap. And roller rockers. What is sniper on that? I don't know what the sniper is. Is it a throttle body that you're using with injectors in it? I don't remember what's an AFR head flow. 250, 260. Are they the straight heads or are they the comp ported ones? or do they have a comp power doing? 260 at 50, so 500. Well, you could make more than 500 horsepower with those. I'm thinking with that cam on a 347 and an air gap, you're going to be in the 475 range. Looking to build a 5.3 for 600 horsepower. Will either heads get me there? None of those heads will, none of those stock heads will make anywhere near 600 horsepower NA on a 5.3. Your 600 horsepower on a 5.3 is very, very difficult. I have some videos up on making 500 horsepower, and I've never made 600 horsepower with a 5.3 other than with boost. To do that is going to be a very, very high RPM, very, very expensive build. I'm looking at two similar cams for my, but if you're talking about doing it with a turbo, any of those heads will work. Just run the stock ones that you have. You can even run a stock camshaft and then just put a turbo on it, and it would make 600. I'm looking at two similar cams for my Gen 3 Hemi. Difference is 20 thousandths in lift. This makes much of a difference in power. Not normally. I saw somebody do a test on lift, and they were saying that it made all this power. But when we did the Truck Norris cam versus the NSR cam, and that went from like 500 to 550 lift, so it was a pretty big change. It was about 6 horsepower, so it wasn't a whole bunch. How well would Patriot Freedom 195 heads flow on a 351? I don't know. I don't know anything about those heads. Have you ever flow tested them? Do you know what they flow? A Holy throttle body. Oh, Tom. Okay, I will. Basically, a plate, 4 standoff tubes, another flat plate, and then a box, and then the blower on top of that. But I'll show you what I'm talking about, because we don't need to use all of the openings in that lower manifold, Tom. Camaro LT1, are you running 1.6 rockers? Would the 1.6 rockers really benefit the LT1 instead of the 1.5 rockers? Just came on the 331 that was in the Fox body. I bought it. Okay. I can tell you that with almost absolute certainty that those heads would be a lot better than a stock head. As long as the heads are in good shape and they're not damaged, I would definitely use those on the 351. Because even a set of ASCAST heads like a trick flow twisted wedge head or something like that, or an airflow research enforcer head, even an inexpensive ASCAST head is going to be like in the 240 or 250 range. And so that's enough to support 500 horsepower. And so you can, it's enough to support good power. With the same AFR 180 heads, I upgraded to a 230. So you went from was your other one a 218 cam and gained 45 wheel horsepower? 218, a 218 228 to a 230 236, and it gained 45 wheel horsepower. Something doesn't seem right from that kind of cam change. I don't normally see that kind of stuff. From just a cam change, that seems like a lot. So let's see. I can take a look. I don't know if I've done that on a 350. I think we did an XFI or something. That was probably on a stroker, though. Let's see here. Here we go. Let's see, how much was this? Stock cam, 246, 268. So we went from a 203, 212 to a 224, 231 camshaft. And it went from 311 flywheel horsepower to 343. And there was a trade-off in power below 3,900. Yeah, below 3,900. And even versus the stock cam went from 278 to 311. So it's 30 something. Going from the stock cam to the 224 cam, that's a pretty good bit. These TFS heads on a 4.6. Yeah, the Trick Flow 2 valve 4.6 heads are better than any of the ported factory stuff. Math on 1.5 to 1.6 is basically making the cam 10% bigger. It changes. I would say it has more of a change in lift than it does in duration. Do you think you'll do any VRS versus Holley carb testing? I can. The Westech has both of those. My guess is that the VRS carburetor would make more power. Camaro. So you're saying that the lobe technology or the ramp rate of the lobe is much more aggressive? An XFI cam should be fairly aggressive, whereas the hot cam might not be. Let's see. I'll get rid of that. Get rid of that. Would you run a 90 millimeter throttle body on your stroker Ford for the street? 79% are saying yes. I think after seeing the dyno results, it would be hard for me not to do that. It would be hard for me to give up that amount of power. And on the 408, it should be the gains that we saw going from a 75 to a 90 on that box upper intake manifold would be even more pronounced on the 408, because it started out already making, what is it, 50 or 75 more horsepower. So that would be quite a bit. That would be a much bigger change. I also wonder about I don't think I remember flowing like an upper and lower box R intake manifold on the flow bench to see what that port flows. And then because of the way that the 5 liter has to be, or 351 rather, but because of the way that has to go around the distributor, the EFI intake manifolds tend to be longer on those two than the others. But I don't know if they were able to get around that. It's been so long since I've seen I have a 302 version of that, but I don't have a 351 lower version of that. But it'd be interesting to see. I'd like to know now what the flow rate is of a Super Victor versus just the flow portion of it, a Super Victor versus the Box R intake manifold. I suspect that a Super Victor would flow more. Zach, you're tearing a Pensar out of a Jeep. Cool. What do you think of a Honda 5-liter single overhead cam VTEC 60-degree V8 they developed for land and sea? So far, only marine version is out. I don't know anything about that. I'll have to go down the rabbit hole and take a look at that. I'm obviously a big fan of Honda stuff. What problems come about on large stroke LS builds? Is an aftermarket block required to make over 427? No, they have a factory 427, so you can run an LS7 block with it. If you're going to try to make longer strokes than a 4-inch stroke on any of the normal LS3, LS2, 6-liter blocks, or a 5.3 or 4.8 block, sleeving it is a good idea because the sleeve lengths are not long enough for longer strokes. Once you sleeve the block, then we've made 454s and 468s and all that stuff out of those. Then it's not a problem at all. And then also you can go to the bore size with assurance that you have enough wall thickness. Because I've seen guys take 6 liters and bore them out to a 6.2, which I don't think is a good idea, but guys are doing it. All my down testing on the stock bottom end LT1 was done with mid tube headers. I switched to long tubes, but never went back to DYNO. The long tubes will definitely make more power, certainly more low speed power. Looks to be based on the J series. I think the J series V6 is really good. Jimmy has one in his NSX. I'd like to run some on the engine dyno and just, kind of show what they do. I think that they're good motors, and they obviously, like everything else, respond very well to boost, and they start out making pretty good power. I think that there needs to be more cam choices for those. And then, ported heads are pretty easy. Luckily, the heads already flow fairly well, but ported heads would be even better. And then different intake manifolds. I think guys are already doing shorter runner intake manifolds. What kind of power would you expect from an LQ4 with 706 heads and a Summit Stage 4 NA cam? I would say near 500 flywheel if you have a good intake manifold on it. Would extending header tubes affect the power and torque? Have to cut and extend the headers for the Hemi to clear the frame rails? Yeah, it will. The primary length of the header is like the intake runner length. So it definitely changes the power curve. It might be if you change it a couple of inches, it's not going to have a dramatic effect on the header stuff. The header stuff doesn't seem to change power nearly as much as the intake runner length does. Can stock blocks with sleeves handle more than 1600 for long-term use? I don't know that the sleeve is the weakness in the block. I think that for high horsepower stuff, stock blocks, I think you run into the caps moving around. So I think you just need more beef in the block everywhere. So the sleeve is not the only thing. There are guys running aluminum 5.3 blocks at that kind of level, but I wouldn't say that it's a long-term thing. You need to extend them by 6 inches or more. 6 inches will probably make a difference. I've run some adjustable header tests to see if we could hone in on where the thing wanted to make the best power with a particular header length. But didn't see dramatic changes on the one that we were testing it on. I've done that on a number of import applications and things also, because we know by changing things like that, we can kind of try to find the power that we're looking for. 81% are yes on the big throttle body. And I wonder now, because now they have, Holley has a high ram available for both for the 302 and for the 351, which means that we have lids available with bigger than 90 millimeter throttle bodies on them now. So I'm sure that you could put a lid on there, a forward facing lid, because it's just a high ram. I think that's the same inlet, or same lower flange, that you could put 102 millimeter, 105 millimeter on there. I think 90 millimeter would be sufficient for most. Certainly any 302 base thing. I don't think you're going to be getting to the point where you'd be making. I mean, you can make 600. You can make 2 horsepower per cubic inch on those motors. It's a really high RPM kind of thing. I think at that point I might start thinking about dual throttle bodies and dual plenums. Talking about big throttle, have you ever mapped waist throttle? What is waist throttle? I'm not familiar with that term. It's vacillating between 79 and 80%. Again, given the fact that we, when did we start getting 90 millimeter throttle bodies? Was that, I think that was on the LS2, right? That we started getting that. Because all of the LS1 and the LS6, those were both like the 78 to 80 millimeter throttle bodies. And we didn't see 90s. None of the 4853 or 6-liter trucks, those are all the small throttle bodies. Only when they went to drive-by-wire stuff. I know that the LY6 was a bigger throttle body. The Recport stuff got bigger throttle bodies because they're making the big power, the big boy power. And obviously, I talked about on this 408 that, and on the 331, we ran boost on the 331 also with his box R intake manifold, and running boost through the throttle body, I think all but negates the power gains that we got from the bigger throttle body. You wouldn't need to have a 90 millimeter throttle body on there. The only reason that I would run that on there is if it made it easier to facilitate the discharge tube size. If the discharge tube size went right on the bigger throttle body, the bigger OD of the throttle body, it was just a silicone coupler or whatever, that would be fine. If both of them were the same, I don't think I'd worry about it. I would use whatever one that I had. Probably not a 60 or a 65, but a 75 would be fine for that. If I had the 90, I would just use the 90. Simple mods: when under boost, run the engine up to red line at wide open throttle, make a second run at 90% throttle to determine where the 10% is really needed, usually only at the very top. So you essentially what you're wanting is a throttle body test, right? You're wanting to see where a smaller or more restricted throttle opening starts to affect power. The issue with doing that with a turbo, if you're controlling the turbo in the manifold, then the turbo is going to spin faster and create more pressure to make that happen if it sees a restriction. That might be a better test with a centrifugal blower. I'm helping a buddy out with his Mustang. It's relatively stock, has E303 cam. He's got a 70 millimeter intercooled turbo. Okay. What kind of boost should be setting the boost controller to? It's a 5-speed. I would set it at whatever the minimum of the spring is, and get it all working and make it work at like 5 or 6 pounds, and then make sure that it's all tuned and safe, and then make sure that it's safe at any boost level above that. I accidentally ordered a 50-liter stainless keg for a gas tank. I figure it'll be enough, especially if I'm going with EFI and the car being so light. Gas mileage should be 25 to 30 miles per gallon. A 50-liter. Well, I don't understand how your fuel tank is going to affect your fuel mileage, other than weight. You should do something undersized, like a 20 millimeter carb bike. Oh, a really, really small throttle body. Once under boost, wide open throttle is not really needed until the top end. That's waste throttle. So you're going to run part throttle through the middle part of the curve because you're just wasting it. Is that what? I don't understand. Maybe I don't understand the train of thought here. If you're tuning it and not seeing 100% TPS, you're going to have some issues with the tuning part of it. I know that. Would a head with 326 CFM intake flow enough? With enough flow, be a big restriction trying to make close to 1600 horsepower? No. That's more than enough. The only thing that's going to stop you from making 1600 horsepower is the size of the turbo or the blowers that you're using. Richard, do you have a tear where you overheated an engine and still made more power? Do you mean a test or a video or something? Camaro, I think an LS3, a stock LS3 is a perfect example of that. A stock LS3 has way too much cylinder head on it. The fuel tank question could be referring to having enough capacity with the mileage in mind. Somebody, let's see. So if it's 50 liters, then it's 13 gallons. 13 gallons is going to be okay with that kind of fuel mileage. It'd be nice if it was 15 or 20, but it'll give you a decent range. Richard, if you have more torque than horsepower on a setup, does that always mean you're leaving horsepower on the table, or is it simply the trade-off of the camshaft? Normally, if you're making your motor combination is making more torque than horsepower, and it's not a forced induction application, then that means you have a relatively mild combination. Because if you look at extreme examples of where we have race motors, a race motor always makes way more horsepower than it does torque. And when you get into extreme examples like Formula One, you might be at 900 horsepower and only 300 or 400 foot-pounds of torque, depending on what kind of, if it's an NA motor and what RPM you're running and stuff. It's just that they've carried that out really, really far. 300 might be a stretch. I haven't done the math on that yet. So if you look at a factory application, like with a tune port application or a 5-liter, where you're making 100 more foot-pounds of torque than you're making horsepower, that's because it's a very mild combination. You can change the intake, change the heads, change the camshaft, and switch those two. Hopefully keep the torque there and just raise the horsepower, which is the best thing to do. And then you start making more horsepower than torque, and then you'll start getting away from the milder combinations and getting into wilder. And then the more horsepower that you make relative to the torque, the wilder the combination is going to be. I've been wondering about going with 75 for my 70 millimeter on my blown Fox body. I keep hearing that the carb being on and off and having drivability. The fact that I don't think you'll see that from a 75, from a 70 to a 75. You might see that more with a 90, but not going from a 70 to a 75. I was implying that I might have a bit of range anxiety for the tank not being big enough, but with the engine being so under stress, I have less range anxiety for for road trips. Yeah, I mean, I would try to make sure that you have a very accurate fuel gauge so that you know, or maybe have, if it's an EFI combination, maybe make a surge tank where the fuel tank pumps up into a surge tank and make the surge tank another gallon or two. We did that on our road race car. We didn't do it because we were trying to extend the fuel range so much, although it did come in handy in one race in particular. But what we were trying to do was get it into this very kind of long and tall surge tank to make sure that we could get every drop of fuel out of the tank. Because in a big tank, even when you put, closed cell foam and stuff in there to stop the thing from sloshing around, it's hard to pick up all of the fuel. So what you want it to do is not be dependent on that picking up the fuel while that thing is moving around, while the fuel gets down to 3 gallons or 2 gallons or 1 gallon. Especially we had 4 corner pickups on the fuel tank, and we could grab fuel and they would pump it all up into this surge tank that we had. It was like about this tall. And then we had our EFI fuel pump in that tank feeding the engine. And so it never ran dry. And so if it overfilled, we had an overfill line going back to the tank. And then we were constantly filling that one from fuel going in the tank. So it was always full. And all the way down to basically the very last gallon of gas, it would keep that surge tank filled up. And then if we ever, it's not a good idea to run it like that, because then your lift pumps are running dry, which you don't want to happen. But if it's that or finishing a race, obviously we want to finish the race. So I see why you bought the 50 liter one. It was $55, and the 100 liter was $200. Yeah, that's a big change, huh? There's a video by HP Academy titled What is torque mapping? That explains torque mapping and waist throttle. That is extremely interesting. Yeah, I'll take a look at that. I don't think you can make more power with less throttle than that wide open throttle. I don't think you're going to make more torque having on a boosted application having less throttle angle. I don't really see how that's possible. Also, let's see, who's our 50 liter? Dylan, might have a spare keg. I think. I don't know how many gallons it is though. What's a typical beer keg? But like I had 2 of them for the keglet on. I plan on a 90 millimeter AccuFab for my 408 with a TFS intake manifold. Good. Building a 410 Windsor, going with a carb NA build, possible booster nitrous in the future. That'll be good. It's going to buy the Holley Hiram for a Fox Body 306 with a Vortec, 15 pounds. Would it be a good intake for the 5.0 with a 90 millimeter throttle body, replacing an Edelbrock Performer upper and lower? The Hiram will definitely make more peak power than the Performer upper and lower, a lot more, as long as you have the other things on your 306. Do you have good heads on it? Do you have a good camshaft in it? A Vortec is obviously going to be helpful. You are going to trade some low speed power from that long runner Performer intake manifold setup to the Hiram. So be prepared to run, at a higher engine speed, which will benefit the Vortec because it's a centrifugal blower and it keeps making power with engine speed. So we'll go ahead and close out our poll at 75. Let's see here. 75% saying yes, they would go with a 90 millimeter. I think I definitely would on a 408, on a 331. I don't know. After seeing the dyno results, it'd be hard not to have that extra. On an NA one, I think I would. On a boosted one, I don't think that I would. And I want to try a high ram on a Ford. I have one for a 351 that I want to run. Infamous. What are you trying to do with it? Nitrous is probably the easiest, least expensive way to go about that. Roots blower probably has the most visual, the biggest visual statement. Turbo will make the most power per pound of boost, and the centrifugal is easy to bolt on. It works really well. Dean, you were on the winning side this time. Richard, have you tested any of the Lenati Voodoo solid roller cams? I don't remember testing any of their solid roller stuff. I've run some of the Lenati Voodoo series stuff on various engine families, but it's all been either hydraulic flat tappet or hydraulic roller stuff, I think. It's a drag car, mainly 8th and bracket races. What I would do, I think, put a nitrous setup on it and then see how it does and see if you like that. And then if you decide, hey, look, I want more power, then I would go turbo. I do homebrew, and kegs can range from 12 liters up to 55 gallons, depending on the setup. Okay. I know what a 55-gallon drum looks like, and it's not that big. One more minute. See, Dean, even what is it? Even a blind squirrel? I used to deliver kegs. These are not the little pony cakes. I remember guys from the fraternity getting those. They're not party balls. They're not pony kegs. It's a regular size keg, whatever that is. I'll look around and see if I have it. See if it has a size rating on it, or maybe I could look up the notes on the keg. My family uses 19-liter kegs for the freezer. Deep freeze modded into a keg fridge. Okay, cool. 160 pounds fully loaded. I kind of remember picking up beer kegs, but 160 would seem like a lot. Especially if it was moving around a bunch. I mean, especially back then, not that I couldn't bench press or deadlift or, that kind of stuff. That sort of weight would have been not a problem. But getting it's not on a bar and stuff where it's easily manipulated. 16 gallons is a normal size. Okay. Plus, especially if you polish it, having a beer keg for a fuel cell is kind of cool. Costs as little as 20 cents a bottle of beer when finished, but usually 50 to 60 cents a beer. I'm not a beer drinker, so that doesn't entice me, but maybe doing my own still for brandy or something like that. Although I don't know that I've ever tried brandy. Maybe bourbon. Like cherry cola bourbon, I think would be good. Or black cherry bourbon. They gave us drop mats to slam them on the ground from the truck. Did that make them foam up inside? I'm leaving it with a beat up finish. It's refurbished. That's good. That's okay. And on that note, it is time to go. I'll see you guys all tonight.